Okay, we're going to talk about solving quadratics by finding square roots today. That's section 4.5 in your book. So here we go. So the first thing we want to do is just actually simplify a square root. So what we want to do is we want to look for a perfect square inside the square root. So just in case you don't know, perfect squares are 4, because that's 2 times 2, 9, 16, 25, 36, 49, dot, 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 2 times 2, 3 times 3, 4 times 4, 5 times 5, so on and so forth. So in 27, what does 27 equal? Or what times what is 27? Well, 9 times 3 is 27. And the square root of 9 is 3. And nothing goes into 3, so we just have 3 square root of 3. We're going to do the same for 98. Square root of 98 is 49 times 2. And the square root of 49 is 7. And the square root of 2 is 2. Okay, not too bad so far? Great. So let's go on to the next one. Just like what we were doing here on the last two, with the square roots and taking the multiplication, I can take my square roots and put them together. Since they're both underneath the square root, I can multiply the numbers together. So 10 times 15 is going to equal the square root of 150. So now I want to find what of my perfect squares go into 150. Well, I happen to know that 25, there's 6 quarters in $1.50. So 25 times 6 is 150. And the square root of 25 is 5. Square root of 6. It's only multiples of 6 are 2 and 3 and 1 and 6. And neither of those are perfect squares. Okay, we're going to move on to 8 and 28. Instead of multiplying those together, I'm going to kind of keep them separate and do this one maybe just a little different. So I'm going to put them inside the same square root. So I have 8 times 28. What times what is 8? 4 times 2. And what times what is 28? 4 times 7. Great, so now I have two perfect squares. I have the square root of 4, which is 2. And I have the square root of 4, which is 2. And left inside my square root, I have 2 times 7, which is 14. So my total is 2 times 2 is 4. 4 square root of 14. Yes, it took a few more steps to do this one, but I didn't have to multiply 8 times 28 and get a big number and then try and find one of my perfect squares that goes into that number. So it is a little bit easier sometimes to keep them separate because you know what the multiples of the smaller numbers are. Okay, we're going to go ahead and go on. Now we're going to talk about square roots with fractions. Still, we're going to do the same thing as when we're multiplying. This becomes the square root of 9 over the square root of 64. And the square root of 9 is 3. And the square root of 64 is 8. And if you can simplify the square root, the fraction after it's out of the square root, please go ahead and simplify that. Okay, what is the square root of 15? Or what times what is 15? Well, 15 is 3 times 5. And neither one of those are a perfect square. So I'm just going to leave my 15 inside my square root. And then what's the square root of 4? 2. There's your answer, done. Very simple. Square root of 11, we're going to do exactly the same thing. 11 is just the square root of 11. And the square root of 25 is 5. Awesome. One more. Square root of 36 is 6. Square root of 49 is 7. Very good. Okay? So fractions not too hard, about the same as multiplication. I do want you to notice that there are no square roots in the denominators. We're going to look at that on my next page. Here we go. So we're going to still do the same thing. I have the square root of 6 over the square root of 5. Now there are no perfect squares in 5. But I cannot have a square root in my denominator, so I need to take care of that. And so to do that, I'm going to multiply by 1. I'm just going to because when you multiply by 1, it doesn't change my equation, correct? So the square root of 5 over the square root of 5. The same thing over the same thing is 1. So I'm going to multiply by that. So that becomes the square root of 6 times 5 over the square root of 5 times 5, which 6 times 5 is 30, and square root of 25. And there are no perfect squares in 30, okay, because 6 times 5, there's no perfect squares in there. So I'm going to have the square root of 30 on top over 5. Awesome. So we're going to move to the next one, which I have the square root of 17 over the square root of 12. Now 12 does have a perfect square in it, so I'm going to take care of that first. 12 is 4 times 3. Okay, and so we'll come down here, and the square root of 17 is in my numerator. The square root of 4 is 2 times the square root of 3. Can't have a square root in my denominator, so I'm going to multiply by 1, the square root of 3 over the square root of 3. Awesome. And I get the square root of 17 times 3 over 2 times 3. Because the square root of 3 times the square root of 3 is 9, and the square root of 9 is 3. Okay? And 17 times 17 times 3 is 51 over the 6. Square root of 51 over 6 is my answer. Okay? Next. Okay, so we're going to do these problems where we have to rationalize the denominator, which is what we've been doing. Cannot have a square root in the denominator. So I do want to just ignore those problems just for one moment, and I want to talk about this. X plus 3 times x minus 3. How do I multiply those out, right? I distribute, and I get x times x is x squared, and x times negative 3 is negative 3x, and 3 times x is 3x, and 3 times negative 3 is negative 9. So then I get x squared minus 9. These two cancel, those two go away. So what it basically becomes is the first term squared and the minus the last term squared. If I have a plus and minus, the same two terms, one added and one subtracted. Okay, so now we're going to look at that with a square root. So if I have 8 minus the square root of 3, and we might as well just do one that I have to do the problem on anyways, I'm going to do 8 plus the square root of 3. And I'm going to do exactly what we just did and distribute out. So 8 times 8 is 64, and 8 times the square root of 3 is 8 square root of 3. 8 times the negative square root of 3 is negative 8 square root of 3. And negative square root of 3 plus square root of 3 is negative 3. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Look, my middle two terms cancel out. Plus 8 and minus 8 is 0. And I'm left with 64 minus 3, which equals 61. So I'm just going to move this out of my way really quick. Okay? Make it a little smaller, move it out of my way. Okay, so if I want to get rid of a square root in my denominator when I have two terms, I'm going to take what's in the denominator and multiply by the opposite sign. I still have to multiply by 1 because I don't want the problem to change, so that means I want to multiply by 8 plus the square root of 3 over 8 plus the square root of 3, which equals 1. Okay, so we distribute on the top, and I get 4 times 8 is 32. And 4 times the square root of 3 is 4 square root of 3, all over, which we already figured out. We already did the math for the bottom part, which, let's bring it back up really quickly, okay, is 64 minus 3, which equals 61. We're finished now, okay? All right, one more problem, and then we're almost finished. So this is 9 plus the square root of 7. So I'm going to multiply by 9 minus the square root of 7 over 9 minus the square root of 7. So distribute on the top, and I get negative 9 plus the square root of 7 all over. Remember, when we distribute, I get the first term squared minus the last term squared. So my first term squared is 81 minus my last term squared is the square root of 7. Well, the square root of 7 squared is the square root of 49, which is 7. So I get minus 9 plus the square root of 7 over 81 minus 7 is 74. Done. Okay? And I do want to point out I cannot simplify these 32, 61, and 4 unless a number goes into all three of these numbers. Okay? So I can't simplify unless something goes into all three. There's a 1 in front of the square root of 7, so there's no simplification that can be done. Okay, almost done. Here we go. So now we want to solve the equation. Well, how do I do that? Okay, well, I'm going to divide by, just like when I solved for x instead of x squared, I'm going to divide by 5, and I get this x squared equals 16. And what does a square? Well, a square root does. Awesome. Okay, and the square root of x squared is x, and that equals 4. Everyone thinks, now you're going to think, okay, I'm done. But I'm really not, because remember, if you look at the graph of this, okay, what I'm finding is my x-intercepts. Well, if x equals 4, I only found one intercept. So 4, if I take x and plug it back in, 4 squared is 16. But what else do I square that gets 16? Minus 4 squared is also 16. So I will have a plus and a minus answer for every single one of these, okay? All right, next question. Add 7 to both sides. Awesome, I get z squared equals 36. Square root of z squared, z equals plus or minus 6. Okay? Very simple, because 6 squared is 36 and negative 6 squared is also positive 36. Okay, one more problem. I'm going to start out the same way as I did the first problem. I'm going to divide by 3. So I get x minus 2 squared equals 40/3. And we are going to leave them as a fraction, no decimals. How do I undo a square? I square root it. Awesome. I get x minus 2 equals the square root of 40 over the square root of 3 plus or minus the square root of 40 over the square root of 3. Now you know we can't keep a square root in the denominator, so I'm going to multiply by the square root of 3 over the square root of 3. And 40 is 4 times 10. Okay, so I have x minus 2 equals plus or minus, square root of 4 is 2, square root of 10 times 3 is 30, all over 3. Add 2 to both sides, and I get x equals 2 plus or minus 2 square root of 30 over 3. Okay, so once again, if you guys have any more questions, make sure you ask in class when I see you next, or come in and see me in the morning or after school. Thank you for listening. Have a great day. Bye.